All right, let's just forget literally everything you've ever been told about scene length, because today, in this explainer, we are completely dismantling one of the most common and honestly worst pieces of writing advice out there. This whole idea that long scenes automatically equal slow pacing. We're going to look at storytelling through a totally different lens today, relying on the really fascinating narrative engineering framework developed by independent researcher Levent Bulut. We're stripping away all those subjective feelings about pacing, and we're going to look at the actual literal physics of literature. We need to figure out why some scenes keep us glued to our seats while others just have us desperately checking our watches.
Ah, the classic advice. This scene is too long. You need to cut it down. We've all heard it, right? It's fundamentally flawed, yet writers hear it all the time from traditional script doctors and literary editors. They look at a stagnant scene and they just give this superficial critique about the page count or how much dialogue there is. But today, we're going to learn exactly why trimming a word count without fixing the underlying mechanics just leaves you with a shorter, but still completely stalled scene. Length isn't the disease here, it's just a misdiagnosed symptom.
So here is our roadmap for today. We'll start with the pacing myth, move into the anatomy of scene inertia, look at the structural causes of narrative drag, figure out why AI text completely falls flat, and finally, how to engineer the fix.
Okay, part one, the pacing myth. You see, physical length is just a superficial metric, a page count. What actually drives a story forward is what Bulut calls causal conductivity. That conductivity is the real engine of narrative flow. I mean, think about it. A 15-page dialogue scene can hold a reader completely spellbound, right? While just a single page of basic setting description can induce unbearable boredom. In narrative engineering, physical length is not the error. What traditional critics are constantly misidentifying as a lack of flow is in reality a breakdown in causal conductivity.
So, a scene drags when it hits scene inertia. Bulut's framework basically treats storytelling as an engineered matrix of perceptual stimuli that targets our nervous system. A scene is essentially a closed channel transferring information and energy. So if your characters spend 10 full pages arguing in a coffee shop, but nobody's structural nodes or relationships actually change, that is scene inertia. The reader's brain registers absolutely zero causal output for the energy it just expended reading. And to conserve energy, the reader's mind just attaches, and they put the book down.
Moving right along to part two, anatomy of scene inertia.
Bulut actually defines the exact thermodynamic equilibrium required for a scene to work through a concept he calls narrative entropy. Think of this like a car engine. If you rev it with highly complex data but don't offer causal pathways to release that energy, cognitive heat accumulates and the engine blows. The reader gets totally overwhelmed. But on the flip side, if friction is zero and all outcomes are just declared right away, the whole system cools off and freezes. Scene drag happens the moment a narrative drifts to either of these extremes.
0. I want you to think of this simple number, delta 0, as the ultimate red flag of a redundant scene. The rate of change, the delta, in a character's internal or external state is what dictates a scene's velocity. So delta 0 means a character exits a scene with the exact same knowledge level, the exact same emotional voltage, and the same physical status they possessed when they walked in. When that rate of change is 0, the scene is generating structural inertia, and it literally doesn't matter how frantic the surface action appears to be.
Let's dive into part three, causes of narrative drag. Bulut outlines 7 primary structural defects that cause this drag, and they range from causal gaps, which is where events are just randomly glued together by the words "and then," causing all your momentum to just collapse, to scenes that are just floating in an unanchored white room, totally devoid of a physical matrix. There's also unconverted potential energy. That's when a scene sets up really high tension, like a ticking time bomb, but fails to convert it into actual physical or causal action. That leads to an early heat death for the scene.
Now let's zoom in on probably the most common trap for writers. Explicit declaration. Bulut calls this told mode, and it creates zero information friction. When an author explicitly spoon-feeds all character intentions, all their emotional states, and the plot facts right there on the surface, the reader's brain doesn't have to perform any inferential reconstruction. Since there's no cognitive load, no narrative heat can accumulate, and without any actual neural work to do, the reader's focus just instantly flatlines.
And this right here is the paradigm shift we're talking about today. Instead of giving a writer some vague feedback like, hey, you have too many details, narrative engineering lets us pinpoint the real disease, parasitic description. This is when you include details like clothing or room decor purely to decorate the space. Unless that description is structured as an inferential puzzle using physical scene residues, like say a material wearing down or a sudden thermal shift, it's just dead weight. It performs zero mechanical work in the narrative system.
All right, part 4, why AI text falls flat.
So in this massive ongoing debate between, say, Google AI and human creators, AI operates on a fundamentally flawed storytelling premise. It naturally defaults to what Bulut calls token probability traps. Because these large language models are just predicting the next most likely word, they create this static rhythm. The prose progresses through these highly statistically predictable sequences. There are no rhythmic shifts, no sensory anomalies, no structural surprises at all. A scene with 100% predictability offers zero signal to the reader's biological operating system. It's perfectly smooth and perfectly boring.
And this is exactly where human narrative engineers will definitively beat the machine every time. AI suffers from summarization bias. It just defaults to declaring surface outcomes. Humans, though, use objective projection. Instead of letting our characters float around in some white room, human writers anchor readers using tangible physical parameters, things like luminous decay, thermal gradients, acoustic impedance, and spatial geometry. These perceptual anchors are what our biological systems actually connect with to experience the story.
Which brings us to our final section, Part 5, Engineering the Fix.
To actually eliminate this drag, you have to execute these precise engineering protocols. Step 1. Liquidate. Delete your evaluative adjectives. Strip away those surface emotional labels and instead encode the emotions into environmental shifts, like dropping the light level or raising the ambient heat. Step 2. Embed. Grab a physical artifact from a preceding scene, maybe a wet coat or a stain on the floor, and use it as a causal lever right now. Step 3. Establish. You need to create causal voltage by forcing the information state at the scene's exit to be at a completely different pole than when the scene started. Seriously, when you apply these steps, you transform what was just a passive dialogue pause into a totally dynamic narrative engine that actively grips the reader. Remember, scene drag is absolutely not a page count problem. When you properly calibrate your information friction and your causal conductivity, even massive, multi-page scenes are going to execute with effortless speed in the reader's mind, all because the narrative is finally doing real mechanical work.
So, I want to leave you with this question to fundamentally challenge how you read and write going forward. Are you just blindly cutting pages, or are you looking at the actual physics of your scene? I highly encourage you to view your stories not as word counts or character limits, but as dynamic thermodynamic systems. Calibrate the friction, establish your physical anchors, and watch your narrative momentum soar. Catch you on the next explainer.